In the late 1950s, the U.S. Navy commissioned the lead boat of a revolutionary class of nuclear-powered attack submarines. It was named the USS Thresher. Built to find and destroy Soviet vessels, it was designed to run quieter, travel faster, and dive deeper than any other submarine in the American fleet. On April 9, 1963, the Thresher departed from the Portsmouth Naval Shipyard in New Hampshire. The crew was heading 220 miles east of Cape Cod for its first set of deep-diving sea trials, following an intensive overhaul. There were 129 people on board. Alongside the military crew, the Navy had embarked 17 civilian shipyard technicians and 4 contractors to monitor the submarine's complex new sensors and weapon systems. The Navy was so confident in the design that it received authority to build 25 more ships of this class before the sea trials were even complete. For the first time since World War II, the military believed it had perfected a general-purpose attack submarine. However, the Thresher's construction relied on a specific engineering choice: silver-brazed joints. These joints were used to connect high-pressure seawater pipes that ran throughout the boat. This diagram shows a standard silver-brazed joint. Prior testing revealed 14% were defective, yet most weren't repaired. The danger was real. Earlier, a joint failure on the USS Barble flooded its engine room with 18 tons of water in just 3 minutes. The Thresher itself had shown warning signs. During a training cruise in 1961, a generator failure forced the sub to rely on battery power alone. Without air conditioning, the internal temperature inside the hull reached 140 degrees before the reactor could be restarted. Despite these incidents, the drive to expand the nuclear fleet during the Cold War took precedence. The Thresher was sent into deep water while these known technical vulnerabilities remained part of the ship's design. On the morning of April 10th, the Thresher began its descent toward a test depth of 1,300 feet. The rescue ship, USS Skylark, stayed directly above, maintaining contact via an underwater telephone. At 9:13 a.m., as the submarine reached the limits of its dive, Commander John Harvey sent a garbled message. He reported minor difficulty, a positive up angle, and stated they were attempting to blow the ballast tanks. 4 minutes later, a final, broken transmission reached the Skylark. The only recognizable parts of the message were the words "exceeding test depth" and number 900. At 9:18 a.m., the Skylark detected a low-frequency noise disturbance. It was the sound of the ocean's pressure instantly crushing the hull. All communication ended. The Navy immediately shifted the mission to a search operation, realizing they had lost the most advanced submarine in the fleet. A ruptured pipe joint sprays high-pressure seawater across a critical electrical panel, triggering an automatic reactor shutdown. The sub loses propulsion and drifts deeper. The crew tries blowing the ballast tanks, but rapidly expanding air freezes onto temporary filters, blocking airflow with ice. A 2013 analysis suggested a different trigger, a purely electrical failure that caused the reactor shutdown without an initial leak. But the fatal result was the same. The search took many months. Eventually, the Bathyscaphe Trieste located the wreckage. The Thresher had been shattered into 5 major pieces, resting on the seabed at a depth of 8,400 feet. The disaster proved the Thresher's design left no room for recovery. A single component failure in the engine room effectively doomed the entire ship. Admiral Hyman Rickover delivered a blunt critique of the program. He argued that the Navy had forsaken basic engineering fundamentals in its rush to make technological advancements. The Court of Inquiry findings were classified for decades. By keeping the report secret, the Navy avoided a public reckoning over its knowledge of the sub's defective joints before it sailed. For the families of the 129 men, the impact was permanent. In Portsmouth and across the naval community, organizations like the Dolphin Scholarship Fund were established to provide for the crew's children. By December 1963, the Navy launched the Sub-Safe program. It established a rigid system of material tracking and mandated that all high-pressure joints and hull welds undergo rigorous ultrasonic testing. The loss of the Thresher changed how the Navy built and inspected its fleet. From 1963 onward, every critical joint and pipe in a nuclear submarine systems had to be tracked and tested against these new safety certifications. 5 years later, the Navy suffered another loss with the USS Scorpion. All 99 men on board were killed when the sub sank in the Atlantic in 1968. During its 1967 overhaul, the Scorpion was denied full sub-safe upgrades to save time and money. The Navy chose to return the boat to duty with its emergency ballast systems listed as unusable. The results of that choice remain clear. Since the creation of SubSafe, no certified American submarine has ever been lost at sea. The Scorpion was the last nuclear submarine the Navy lost, and it was never certified. Because the investigations into both the Thresher and the Scorpion remained classified for so long, they have been the subject of persistent debate regarding what exactly happened in those final minutes. Today, no American submariner goes to sea in an uncertified boat. The 129 men of the Thresher paid the price to establish an engineering standard that has protected the submarine force for over 60 years.